Hi everyone, welcome to the third part of this series on making a handheld gaming console from scratch. So in this video, we're going to add the shooting or the firing capability to our player, that is our tank. So on pressing the fire button, our tank will be able to shoot bullets towards the aliens. And we'll also do some basic collision detection, wherein if the bullet hits one of the aliens in the group of aliens, that alien should die or rather get destroyed, and the bullet also should get destroyed. So by destruction here I mean the alien should that particular alien which the bullet hits should get removed or should get vanished from the group of aliens, and as well as the bullet that is hitting the alien should disappear. So the things we'll be focusing on here is like how to keep on spawning bullets whenever you press the button, so how we can maintain a dynamic list of bullets, how we can make them move, and how we can check the collision between the bullets and the enemy, right? So this is what we are going to do today. I'll try to keep this video short so that we only focus on bullet spawning and collision. So yeah, that's it. As always, let's get started. Okay, so the first thing that I'm going to do before starting anything is get rid of these two if statements, because we now don't want our player or our tank to move up or down. We only want to restrict its movement in the horizontal direction, that is left and right. Coming to bullets, the first thing that we need to decide is how the bullet is going to look like, right? So earlier what we have done is we have maintained bitmaps, or we have used bitmaps which are 8 columns in width and 4 rows in height, right? However, bullets are largely cylindrical by nature. What we would want is a bitmap which has got more height than width, so it will be a really thin bitmap. So let's quickly draw our bullet. It will be very simple. What I want for my bullet is it should be 8 pixels in height and 2 pixels in width. So pretty much like this. That's our second column. So 2 pixels in width, and that's 8 rows. And how I want to make it is something like this: 0 1 1 0. So alternating ones and zeros in every row and column. So why did I do this? I want my bullet to look a bit zigzag. So this, what it will get translated in on the screen is something like this. So I want to have a thunder-like zigzag shape, something like this, right? So roughly something like this is what I want my bullet to look like. So now we know that how our bullet is gonna look like. Let's see how we can create it. So first let's decide what structures we'll be using to represent our bullet. So let's go to spaceinvaders.h, the header file, and let's create a bullet type structure. So for that, what I'm going to do is I'm going to create a new type def struct. As usual, it will have a pos x, a pos y, a speed parameter, and whether the bullet is alive or not. And we will call it bullet underscore t. The other thing that we are going to have is something like this. So I'll explain in a moment what's bullet node. Okay, let's call it bullet node t. Okay, so that's a tiny bullet node. So what's bullet node over here? So with bullets, what happens is whenever you press the fire button, a bullet should get spawned and immediately it should start moving up, because the tank is located towards the bottom part of the screen and the aliens are above. So the bullet, as soon as it gets spawned, what should happen is it should move up. And now no matter how many times I press fire, a bullet should get spawned, right? We cannot maintain a static list of bullets because we don't know how many bullets will there be on the screen at a given point of time. So what we need here is essentially a dynamic array which can grow. For that, in C, what we can do is we can maintain a linked list of bullets. So we can use a linked list where each node will be a bullet. Essentially we'll have the bullet information and it will also have the reference to the next node. Pretty much a basic linked list. So first we define our bullet type, which has got POSIX, POSY, speed and alive, and we have got our bullet node, which is basically the node of our bullet linked list. The other thing that we are going to do, even before we start coding the shooting mechanism, we are going to introduce a new button. We are going to give it the pin number 10. We also need to remember that we need to initialize the fire button. So for that, I'll do fire comma input pull up as for the others. And the other thing that we need to do is here we need to take the input. Fire. So now let's declare our bitmap. Let's define our bitmap. So our bitmap will be something like const uint 80. Let's call it bullet bitmap. It will be 8 pixels in height, which means it will have 8 rows, and 2 in width, which means it will have 2 columns. So let's define it now. 0, 1, 1, 0, and it will be pretty much the same for the rest of the rows. One more time. Yeah, now we have our bullet bitmap. The other thing that we want now is not uint 8 but bullet node. I believe we will have to do a forward declaration here since it's not being able to resolve, which means since it's not being able to resolve bullet node underscore t, I believe it's better to do a forward declaration here. So let's do that. So what we'll do is we'll not do a type def, but we'll do a struct, and then we will call it like we'll remove it, and separately we will create the type def. Bullet node underscore t. So now it should hopefully it should be able to resolve. Let's go back to space invaders.ino, and yes, and we are going to call it tank bullet list. So this is pretty much the head of our linked list, or basically the starting point of our linked list, which will be containing our bullet nodes. So first let's see how this entire thing is going to look like from the update perspective. So right now in our update, like space invaders update, we have something called process input. Let's move process input up. So in this process input, we are evaluating all our inputs. So our fire button evaluation is also now in process input, and it's here we need to do like something like if someone presses the fire button, we need to spawn a bullet. So once the bullet is spawned, what we need to do is we need to update the positions of those bullets. We need to make them keep moving up the screen. So for that, let's say we'll define a method called update. The method is not declared right now, but we'll do that. So that will be there. And the other thing that we want to do after, once we have updated the bullet position, let's say we have moved every bullet in the screen by 1 unit up, what we need to do is we need to check if it has collided with the alien. So for that, let's do something called check alien hit, which simply says if the alien has been hit. Okay, these two methods we don't have now, so it's better to keep them commented out. So first let's see how we can spawn a bullet on the screen. Let's keep it under our spawn alien function. So let's call it spawn tank bullet, and we want to give it two parameters. One is pos x, like where we are going to spawn it, basically the position, pos y. So now let's create an instance of bullet. So bullet type bullet equal to, we are creating a new bullet, pos x dot pos y equal to pos y dot speed equal to 1. Right now I'm giving it a static speed of 1. We can change it later if we want. And the bullet is alive initially, right? Okay, next what we are going to do is we are going to create a new node out of our bullet, or rather for our bullet. Bullet node t malloc size of course bullet node t. So once we have got our bullet node, b node created, what we are going to do is we are going to set its bullet property to bullet, and we are going to set its next equal to, as of now let's make it null, and then we need to check whether this is the first bullet in the list. If that's so if our bullet linked list head is null, we know it's the first bullet, and we make it we make the new bullet, the newly spawned bullet, the head. Okay, and we are done. Otherwise what we are going to do is we are going to create a temporary reference to our bullet list head, and then we are going to traverse to the last node. Again, we can always keep a running reference to the last node of the bullet, but as of now I'm going to do this way. So I'm pretty much traversing the linked list to the last node. And once I'm at the last node, I'll make its next point to the new bullet. So it's classic addition of a new node to the end of a linked list in C, right? And that's pretty much it. That's our spawn bullet function. And from where are we going to call this? We are going to call this from our process input. So we are going to do is in our process input function, we are going to check if fired val equal to 0, which means the button has been pressed. What we are going to do is we are going to spawn the bullet, basically call the spawn bullet function that we just now defined, spawn tank bullet. So now we will have to give it the position at which we want to spawn it. So where I want to spawn it is at the mid position of the tank, right? At the mid position of the tank. So let me first write the code and then I'll explain what I am doing. So tank.pos x plus tank.width by 2 minus 1. I'll explain in a moment why I did this minus 1, but it's necessary for proper alignment of the bullet position. And tank.pos y minus bullet height. This also reminds me, we need to define bullet height and bullet width. So let's do that quickly. So we'll go back to space invaders h, and what we are going to do is define define bullet height as 8 and bullet width as 2. Now we have got bullet height. It should resolve. Yes. Okay, so what did we do here, and why did we do this width by 2 and -1, all those things? So what we essentially want is something like this. Let me just remove everything. So let's say this is our tank bitmap, which has got 8 columns, 2 3 4 5 6 7 and another 8 and 4 rows. And remember, our bullet is 2 pixels in width and 8 pixels in height, and what I want is I want the bullet to spawn at the exact midpoint of the tank, like because the cannon or the mouth of the cannon is somewhere in the middle, right? So I want it to be spawned at exact midpoint, and also I want the lower edge of the bullet to coincide with the upper edge of the tank. So I want the lower edge of the bullet to be somewhere here. Since it's an even number of pixels, and luckily our bullet, not luckily but very intentionally, our bullet width is also 2. In order to have the midpoint, we'll have to place it somewhere here. So this will be the bullet coming out of the tank. Now if you see, if this is our POSIX px and the width is 8, so px plus 8 by 2, which is pretty much width by 2, will give us this point, will give us this pixel, the beginning of this pixel, right? Because it's px plus 4. Since this is px, this cell here is px plus 4 will give us 1 2 3 4. So if we simply add 4 with px, we will be getting this pixel or this cell, but we don't want this cell. We want the bullet printing or the bullet display to start from this pixel, the midpoint. So that's why we do a -1. So we get this one, right? So I had the width of our bullet be odd number, which is 3, something like 3, then we would have been in trouble, because no matter what we do, it would never get aligned with the midpoint of the tank. But since the width of our tank is even and our bullet width is also even, we can align it with the midpoint of our tank. So now we know what's the starting position of the bullet, and we know why. And also, before moving forward, we do tank.posy minus bullet height, is because we want to start drawing the bullet from this somewhere over here, so that as I mentioned, so that the lower edge of the bullet coincides with the upper edge of the tank. That's why we do a tank.posy, which is posy is pretty much this edge, represents this line, minus tank height, which is 8. Now that we know the starting position of our bullet, we call the spawn function, which spawns the bullet. It simply spawns the bullet, that's it. The next thing that we want to do, as mentioned here, is we want to update the tank bullets. So we want to move them, we want to make them move up continuously. Let's see how we can do that. So what we're going to do is we are going to create a function called update tank bullets, and once again it's pretty simple. We are going to once again traverse our bullet linked list. Once again we are going to create a temporary reference to our tank bullet list. The reason we create temporary reference is because we are going to keep on updating this t head. If we do it with the actual list head, we are going to lose it, and we won't be able to reiterate again if we lose the head of a linked list. So while t head not equal to null, that is, there is no more t head, there is no more nodes remaining. If t head so remember, if every node has a bullet property, and so if t if t head bullet dot alive equal to 1, that is if our bullet is on screen and is alive, we need to move it. So if the bullet is alive, what we are going to do is we are going to decrease its y position by speed. Decreasing y position means it's basically moving up. So let's do that. T head dot bullet dot pause y minus equal to t head dot bullet dot speed. And next we want to make sure that if the bullet goes outside the screen boundary, we want to make its alive value to 0. So we want to destroy the bullet if it goes outside of the screen. So for that, what we are going to do is we are going to check if t head dot bullet dot pause y is less than 0, or t head dot bullet dot pause y is greater than screen height. What we are going to do is we are going to make t head dot bullet dot alive equal to 0, and just outside the if statement but inside the while, we are going to go to the next node. Okay, so that's how we traverse all the bullets until the very last bullet, and we reduce its y position by bullet speed so that it moves up, and at the same time we do some boundary checks. If it's outside the boundary of our visible screen, we make its alive value to 0. So far so good. Actually, we can get rid of this condition. So what happens is if the bullet keeps on moving up, keeps on going up, it will at a point of time its value will become 0, and the next time when a subtraction happens, since we are using uint8, I believe, let's double check. Yeah, since we are using uint8, a negative value would mean basically it will get wrapped up to the last value of unsigned 8-bit, which is 255. So what I'm trying to say is if bullets pause y is 0 and we again subtract 1 from it, it will become 255, which is greater than a screen bit. So anyways, if it goes above outside the screen, this condition will get satisfied, because obviously 255 is greater than a screen bit, which is 64, and our alive value will become 0, so the bullet will get destroyed. So this condition should suffice. Okay, so now we are updating the bullets, and we have this function, so we can uncomment it. So now the final thing for spawning bullets, what that is required is rendering the bullets. So let's see how we can render the bullets, or rather draw a bullet. So I'll keep it just below draw alien. So I'll do something like void draw bullet, and again it will have a pause x as usual, pause y, and for size t row equal to 0, row less than 8, row plus plus. Basically we'll use the same, just how we are drawing all the bitmaps, we will draw this as well. Again, this could have been a common function which receives a bitmap and length and breadth, but as of now I'll be doing like this: all equal to 0, all less than 2. If bullet bitmap row all equal to 1, then mono display dot draw pixel. That's it. And back to our space invaders render function, which is somewhere I believe here. Once again we are going to traverse. The list while t head not equal to null if t head bullet. Now it's very important to check whether the bullet is alive or not. What we are going to do is we are going to draw bullet t head dot bullet dot pos x comma t head dot bullet dot pos y and t head equal to t head next, and that's it. Now let's check what all we did. We have a process input function where we are checking if fired equal to 0, then we are spawning our tank bullet at the midpoint of the tank, right? And then in the spawn we create a bullet node, we add it to the end of the bullet list, and then we have something called update tank bullets. What update tank bullets does is it pretty much loops over all the bullets in our bullet linked list, and if it's alive we simply decrement its y position by its speed, that is 1, and if it's outside of our viewing port we make it alive to 0. And yeah, that's pretty much it, and ideally it should work. Let's see, let's try to build it. We have got a few errors it seems, so let's fix those. Makes sense. I believe this was causing a bunch of issues, so let's quickly compile once again to see if what errors got removed. Line 43. Spawn bullet. So something is wrong with spawn bullet. Spawn. Oh, here there will be a semicolon, and I believe another will be where it's being invoked. Yeah. Okay, so there is no fired valve. Why there is no fired valve? Let's check. Okay, I named it fired, that's why there was no fired valve. Okay, so I believe the other issue is here. It should be casted to a pointer type, and now let's compile once again. Okay, it did compile successfully. Yeah, so let's now try it out on our board. So I'll deploy it from here. Okay, so this is the deployed thing on the board, and I have made that move down flag variable to 0, which we discussed in last video, so that the aliens doesn't move down. And I have also added a new button. Let me just move the wires a bit so that it's visible. I'll remove these two up and down buttons soon, but as of now I've just kept it because these are no more necessary. I've connected the button to our common ground with this black wire, and with this blue wire I have connected it to the pin number here. Very similar connection, just like all the other buttons. So which pin number was it again? I believe 10. Yeah, so the fire button is connected to 10. Now let's see how it works out. So if I press the left button it goes left, if I press the right button it goes right, if I press up nothing happens, down nothing happens. And now let's see the fire button. So this is the fire button, and if I press it, so hopefully it's visible, the entire thing. Yeah, so if I press it, see, I am able to shoot. So even if I move I am able to shoot. It always shoots from the right place, that is the midpoint of the tank. However, one thing what you'll notice is if I keep the bullet, if I keep the fire button pressed, it shoots in a very weird way. That's because it's trying to spawn too many bullets at the same time, and the bullets are getting overlapped, and it's giving us a very weird effect. And also it's throwing a large number of bullets at the same time, which even if it would have worked in the proper way, it would have kind of spoiled the game for us, because that's just too many bullets and it will be very easy to kill all the enemies, right? So this is something that we'll have to fix. We don't want a continuous stream of bullets to come out of the tank if we keep the button pressed. What we want is the bullets come out of the tank, or the tank is able to fire bullet with some probability, right? And also, like, at one time we should be able to fire only one bullet. So if we keep the button pressed, it should not try to spawn too many number of bullets. It's so two things, like one bullet at a time, and it should be able to fire with a probability. So these two things we need to do. And there is another catch, or there is another nuance here. So right now, even if our bullet is dead, it's still in our memory, because the bullet is not actually removed from the linked list. We are keep on increasing the memory under use, but actually not doing anything with the memory, since the bullets are not visible, right? So what we need to do is, we need to have a mechanism or a process in place such that once the bullet is outside of the screen, or once it has hit an alien, it should get removed from the linked list as well, and the memory should get freed, right? So this is something which we need to do as well. So let's see how we can do those things. One is controlling the flow of bullets, and other is removing bullets, or pretty much garbage collection. Okay, so first what we are going to tackle is the bullet flow issue, or rather the bullet spawn restriction. So for that, what I'm going to first do is, I'm going to introduce a new variable called fired, and I'll initialize it with 0. And then in process input, what I'm going to do is, I'm going to add another check, and I'm going to check if fired equal to 1. Then I'm going to spawn a bullet, and immediately after spawning a bullet, I will make fired equal to 1. And if the button is not pressed, or it's released, then I'm going to make fired equal to 0 again. So let's see what's happening here. So what this will make sure is, only one bullet is spawned every time we press the button once, right? So it will prevent multiple bullets from getting spawned when we keep the fire button pressed. How this makes sure of that is, when the game boots up, fired is 0, because we initialized fired with 0. So when now someone presses the fire button, what happens is, we check that whether, sorry, it won't be 0, it won't be 1, it's 0. We check that if fired is equal to 0, which of course it is, because fired has been initialized with 0, it will spawn a bullet, and immediately it will make fired as 1. So it's like a flag which says that the bullet has been fired for this button press. Next time when we again check and find fired value is 1, if let's say I'm keeping the button pressed and holding it in that position, it will see that fired is no more 0, but fired is 1, and it won't spawn a new bullet. At this point of time, if I release the fire button, then in the else part, because fired value won't be 0 anymore, so the else part will become active and fired will be reset to 0. So next time again, if I press the button once again, so it will find that fired is 0 and it will spawn a bullet. So it's very simple but very effective. It's an effective guard preventing us from generating multiple bullets on keeping the fire button pressed, right? The other thing that now we are going to do is clean up the bullets which are out of the screen or which have hit the alien, so that they don't hog our memory. So for that, what I'm going to do is, I'm just, after spawn tank bullets, I'm going to create a new function called clean tank bullets. So first, the case that we are going to tackle is, let's say, so it's a list of bullet nodes, right? So the dead bullet can occur anywhere. Also, one case is that there can be multiple bullets at the start of the list which are all dead. So let's first tackle that, or handle that situation when the list starts with a continuous number of bullets which are all dead, that is not alive. So for that, what we are going to do is, bullet list while t head not equal to null and t head dot bullet dot alive equal to 0. p underscore t start tmt equal to head. So this is the simpler part, wherein we simply traverse our linked list from the very beginning. Whenever we are finding a dead bullet, we are simply replacing it with the next bullet. Again, if the next bullet is also dead or it's not alive, we are replacing it with its next bullet, and we keep on doing this until and unless we reach a. So we keep on doing this until we reach a, or we hit a bullet which is not dead yet or which is still alive. So it's like we keep on traversing the list from the beginning, and we quickly keep on replacing the dead bullet with its next reference. Now comes the next part, where we search for bullets which are dead but which are occurring in the middle of the list. So for that, what we are going to do is, once again, okay, before proceeding, the other thing that we need to do is, we would want to replace our bullet linked list head with the alive bullet, right? So if I try to explain it a bit better using visualization, so it's like we have, so let's say this is the bullet linked list, right? And so let's say 1 equal to alive and 0 equal to dead. If that is the case, so let's say this is dead, this is dead, this is alive, this is alive. What we do is, we start here, we create a temp node, and we point it to this one. So now if we see that this is dead, what we do is that we make it point to, we make temp point to this. Again, since this is also dead, we make temp point to this. Since this is not dead, so the loop will break, and now this is the first node in the list which is alive, for which the bullet is alive. And what we will now do is, we will make the actual head of the bullet list point to this one. So this becomes the new head. Okay, so far so good. Now we need to tackle the case where bullets, the dead bullets, occur in the middle of the list. So for that, what we will do is, we will create a variable called prev or previous, and we will initialize it to 10 bullets, and while prev not equal to null, so we are creating a temporary head or temporary reference to the next of previous, which is pretty much the next node. And now, so the case can be that whenever there is a dead bullet in the middle of the list, it can be pretty much a beginning of a continuous stream of bullets which are all dead, right? So now we do pretty much what we have done here. So we'll try to get rid of all those continuous stream of dead bullets. So while t head not equal to null and t head bullet dot and we will free the deleted node, right? I will do prev dot next equal to t head and prev equal to prev dot next. So what essentially this will do is that whenever it finds a dead bullet in the middle of the linked list, it will start a new loop starting from that dead bullet, and it will keep on deleting all the dead bullets that comes after that continuously, and again it will reset its previous and start the process back. There can be better approach to solving this. There might be a way we can combine these two. I'm pretty sure there will be a way to combine these two in a single loop, like this case and the generic case in a single loop, but as of now I'm going to go with this approach. Okay, so that's pretty much it. Let's see if it looks good. So first okay, and now from where we can call it is from here. We will do it after check alien hit, because after the alien is hit with our bullet, that will also destroy the bullet, and so we will just garbage collect all those bullets in the same go. Okay, so before going forward, let's compile it once. Oh, that's my bad. Let's try to compile it once again, and it got compiled. Okay, so now let's try to deploy it on our board, and let's see how it looks on the board. Here's our fire button once again, and let me press it. So now you can see all the bullets are completely visible. The entire width and height of the bullet, like that is 8 rows and 2 columns, it's fully visible. And one more thing that I just forgot to do is adding the probability while spawning the bullet. So let's do that quickly, and then we will continue. So right now, as you saw, is whenever we press the button, a bullet is getting spawned. So that again kind of spoils the game, because you are able to spawn too many bullets too quickly, right? And since the screen is small and the number of aliens are also small, if you are able to kill all the aliens so easily, there is no fun in the game. So what I'm going to do is I'm going to spawn the bullets with some probability. So for that, what I'm going to do is I'm going to head back to our process input, no, not process input, but spawn tank bullet function. And even before starting to do anything, I'm going to create a new variable called called chance. So what this will essentially do is it will generate a random number between 0 and 10, and then I'm going to spawn the bullet with a 70% chance. Right, so since it spawns between 0 to 10, and if the number generated is above 6, whether that is 7, 8 or 9, I'm going to return without generating or spawning a bullet. So 7 out of 10 times, which is 70% of the times, the bullet will be spawned, and for the rest 30% it won't be spawned. So it will add a subtle jitter to the bullet spawning. So let's see how it looks. Let me deploy it. So as you can see, some of the fires will be a blank fire, right? And there will be gaps between in the stream of bullets that's coming out. So on every press you won't be getting a bullet coming out of the tank. Light jitter has been added. So yeah, that's it for the bullet flow control, and obviously the cleanup of the bullets you can't see on screen, but what essentially will happen is whenever the alive property of the bullet will be set to 0, the bullet will get removed from the memory. Now that we have functioning bullets and everything which moves, let's add some collision detection and let's kill some enemies, or let's hit some aliens. So for that, first we need to find out how we are going to do collision detection. So collision detection usually works on simple principles of boundary check, especially for 2D collisions. When it becomes 3D, it becomes more complicated. Even in 2-dimensional graphics, it also sometimes gets complicated when you have a complex character which has got different components like a arm, legs and all. Then you don't want to consider the entire thing as a rectangle, right, or a blob. You want to consider the different objects of which the player or the object is, different components of which the entire object is composed of. You would have a different collider for its arms, different collider for its body, for its legs, In this case, you would have a different collider for the cannon of the tank, for the body of the tank, but we don't want so many things, right? We just want to see if the bullet is close enough to the alien such that there is a overlap between their boundaries. We want to destroy the alien, right? As simple as that. Let's say this is our alien, which is again a rectangular bitmap, right? You can consider the alien inside it, something like this, right? As I mentioned, we won't be doing any detailed collision checking, but just consider this entire alien as a rectangular blob. And we have our bullet. Again, you can consider it zigzag inside it, something like this as we created. What I essentially want is the moment this edge of the bullet hits this edge of the alien, like it happens like something like this, right? Something like this, such as these two things collide, right? These two edges collide. I want to destroy the alien. I want to mark the alien as dead. I want to mark the bullet as dead. So basically, this is my collision that's happening. I don't want to completely overlap, but just when it coincides, right? So one thing obviously we can do is we can check the boundaries. We can see if this or the position y of this thing, position of y of the bullet is less than the y plus height of the alien. We can go that way and do a bunch of if else to find out if there is a boundary cross or boundary coinciding happening. But what I am going to do in this case is something different. Since it's a Cartesian plane, two-dimensional plane, what we can always do is find the distance between the alien and the bullet. So in this case, what I'm going to do, rather than considering this bottom edge collision with the bullet's top edge, what I'm going to do is I'm going to calculate the distance between this position of the bullet. So this is basically bullet's px and py, this position from the midpoint of the alien. I'm going to calculate this distance, and if this distance is very less, right, if this distance is very less, it means I would consider a collision has taken place and I would destroy the alien and the bullet, right? So this becomes way easier than doing all this kind of if else condition and everything. Since our screen is also very small and our objects are very small, collision detection with boundary checks doesn't make much sense, and we can take advantage of the Cartesian distance. So we will use the classic formula of, let's say if this is px py and this midpoint is mx my, we will use a classic formula of Cartesian coordinate distance, which is x2 minus x1 whole square plus y2 minus y1 whole square, and we'll take the square root of it. You can try experiment with different distances, but what I found is that 4 works pretty nice, pretty decent. If this distance is less than equal to 4, so if the distance is less than equal to 4, it's a collision and we will mark the bullet and the alien as dead, right? So that's our simple collision detection using Cartesian coordinate distance. So let's try to code this. So what I'm going to do is I'm going to create a new function called getDistance, and this is a generic function. It will just compute the Cartesian distance between two pair of coordinates, y1 comma u in a t x2 and u in a t y2 x1 y1 x2 y2, and return double of xqrt, and again we'll do a pow because we need to power the individual x2 minus x1 and y2 minus y1. So let's do that. So it's x2 minus x1. Again, sign doesn't matter because we are taking the square, and again pow y2 minus y1 comma 2. Okay, it's not 0, it's 2, my bad. and here there will be another bracket. So let me quickly check the back brackets. So pow 2, another pow 2, and the entire thing is under square root, and let's make it 2.0 as well. So x2 minus x1 squared plus y2 minus y1 squared, right? And this entire thing I am summing, I am doing a square root, and I am casting it to double. Next I'll create the function that I mentioned earlier, void check alien hit, and once again I'll loop over all the bullets, because here what happens is that, let's say there are n number of bullets on the screen and there are m number of aliens in the screen, so I need to once again do a Cartesian product between the bullet set and the alien set and see if any one of the bullet hits any one of the alien, right? So it will be n cross m combinations that we need to try out. So let's do that. Start t head equal to 10 bullet list, while t head not equal to null. Okay. If the alien is not alive, it's dead, we can't kill it again, so we'll just ignore that. Now we will invoke our distance calculator. And remember, we want to calculate the distance from the midpoint of the alien. So for that, what we'll do is we'll do aliens I dot cos x plus alien width a2 and alien I cos y plus yeah, so that looks good. And if this distance is less than equal to 4.0, what we are going to do is t head dot bullet dot alive. So this means a collision has happened or the alien has been hit, so destroy the bullet as well as destroy the alien. And of course we need to continue with our iteration, so t head equal to t head dot next dot next. And now what we can do is we can comment out this one. Okay, so hopefully this should work, and let's compile it. And there are quite a few errors. Let's try to solve those. Oh, it will be alive. Okay, so it compiled successfully. Now let's once again deploy it to our board. Okay, before trying it out on the board, I missed one thing which we need to do now, and that is what we need to do is we need to go back to our render function. Before drawing our alien, we want to make sure that the alien is alive. you can actually simply continue as well. Yeah. Okay, so now let's deploy. Again, typically we could have also used linked list for the aliens, as I might have mentioned before. In that case, we could have done something similar to the bullets, wherein if an alien was dead, we could have simply removed it from the list and from the memory. Since the total number of the aliens is static, it's 28, it's not going to keep on increasing and hog our memory. So I believe it's fine if the number stays constant for this tiny game. Okay, so it's deployed. Let's see how it looks. And now if I try to shoot the aliens, see, we are able to kill aliens. Let's kill some more, and you can see as soon as the detection happens, the collision detection happens, the alien vanishes as well as the bullet vanishes. Cool. You can, if you want, you can also play with the bullet generation probability factor. If you feel that still it's spoiling the feel of the, or it's spoiling the fun of the game, you can reduce the probability with which the bullet spawns further down, which will reduce the rate of tank bullet spawning. It's up to you. So yep, I believe that's it for this video. So we did quite a few things in this video actually. We saw how to create bullets, spawn bullets, how to maintain a linked list of bullets, delete, clean them from memory once they are dead. We saw how we can detect collisions between the bullet and the alien using Cartesian distance. And now we have a working shooting mechanism and collision detection mechanism. In the next video, what we are going to do is we are going to make the aliens also fire back at us, right? And it will be a bit different from the tank firing, because tank firing is on demand, right? Like the tank should fire when someone presses the fire button, but with the aliens it should be like a continuous thing, or rather a continuous process every now and then. So at a certain frequency, randomly one of the aliens should be able to shoot at us. So we are going to look at that, and also if possible we'll also try to implement the concept of lives, like how many life our player will have. When all the lives are gone, the game will be over. So those are the things we are gradually going to do. So yeah, that's it for this video. Thanks a lot for watching, and see you all soon.